Thank you, Professor Lee, for this very nice introduction, and thank you again for inviting me over to this wonderful gathering to talk about my research, and also thank you, Professor Xu, as well, to invite me. So yeah, thanks to Professor Lee. I think now probably our audience and first good evening to most of us, and for those of you who are not in my time zone, maybe good morning or good afternoon. So yeah, thanks to Professor Lee's introduction, nice introduction. I guess like you guys know me a little bit right now. So as Professor Lee kindly suggested, my own research area is mainly in transportation economics and policy. So yeah, so we have about 1 hour. So I think I can talk about one of my working papers right now. But most importantly, I think for um, many of our audience who may not be very familiar with aviation, because like today we're going to talk about aviation. I would also do a little bit of, I probably will spend maybe half of the time, giving more background introduction so that hopefully it will be kind of inspiring for, new research collaboration and research ideas, right? So yeah, so that's the reason why I actually propose a very generic title for my presentation. So the focus will be sustainable aviation fuel. If you don't know what SAF or sustainable aviation fuel is, don't worry, I will explain in a minute. And I would talk about the policies of SAF, like logistics and also, of course, supply chain management or supply chain of SAF, right? So, but that's a very generic um, title, I would say. So as I mentioned, I'm going to probably divide my talk into two parts. And the first one would be a more general background introduction. I will first introduce what SAF is, sustainable aviation fuel. And of course, like followed by the policies, logistics, and supply chain issues, which I find very interesting. And it's a pretty new research topic, I would say. So I think there are a lot of low-hanging fruits to be reaped, as research topics. So of course, I will also, talk a little bit about the existing, like mainly my own research in this area, and also like some future research plan, or closely related to the background introduction that I will do in a minute. And then I will spend maybe like another 20 minutes or even shorter than that to discuss or introduce one of my current working papers. And yeah, so as I mentioned, I think it would be very nice if you just don't worry if you have any question during my talk, just maybe just unmute yourself and then speak up, and then we can discuss. Right? It's it's the main purpose is for discussion. Anyway, so without further ado, let me get into the introduction. So as Professor Lee nicely introduced, like this forum, this very nice forum, at least like this particular session is about sustainability. And one of the focuses is sustainability, right? So this is also related to our talk or our topic. So sustainable aviation fuel is related, or is like one of the major means for the decarbonization of aviation. So I guess like we know that decarbonization is very important. And aviation as an industry actually kind of contributes to about 2 to 3% of all the global greenhouse gas emissions. 2 to 3% doesn't sound a lot, but if you consider, that to be the percentage of aviation in terms of its contribution to all the human-made, greenhouse gas emission, then it's quite substantial. But what makes things even worse is that, two factors. One is that aviation is still fastly growing, right? So, there are still a lot of, or a majority of the global population that hasn't even taken any flight yet, and we now see that those very large developing countries like India, they're also like having a very large population that hasn't had a lot of chances to fly, but will definitely do so in the near future, right? So that's one. Two is that, I mean, when we have more air traffic, of course, we expect to have more uh, carbon emission from aviation. The second factor is probably more prominent, and that is the fact that aviation is notoriously hard to decarbonize. So there, we know that right now the electric vehicle industry in China is very, very strong and also powerful, right? So urban transportation has been largely electrified, and also so it means that there will not be as much emission as before, and we will be able to achieve relatively quick decarbonization for urban transportation. But aviation is not so lucky, right? Because of technological barriers, so the energy density of battery definitely will not be able to support long haul flights. So we still heavily rely on jet fuel or aviation fuel, which makes it very, very hard to decarbonize. Right. So decarbonization of aviation in itself is a very big topic, which can we can spend a lot of time talking. But the basic idea, what I want to illustrate in this particular graph is that the industry actually has reached a consensus. We have, I would say, explored as an industry, the aviation industry has explored many different possibilities in terms of decarbonization, right? So one is operational efficiency improvement, and I have to say, the industry as a whole has been doing a very, very good job in that. So we don't really have a very a lot of chances to achieve a major reduction of carbon emission just by improving the efficiency um, of the airplane, just like what we have been doing. So the industry and new technologies like battery, the electric planes or hydrogen planes, right? So those are promising, but they are very far away from being commercialized, right? So they're technologically speaking, they are probably like more than 50 years away from being really possible to be commercialized, right? So the consensus in the industry is that SAF, sustainable aviation fuel, would be in the short to medium term would be the major solution for aviation decarbonization. All right, so you can see that the majority, the green shadow in this graph, they are all sustainable aviation fuel, right? So the majority of the decarbonization would be taken care, like by 2050, will be taken care of by SAF. So what is SAF? Like, to make it very simple, SAF is just like the alternative, like the clean and alternative fuel. So one example, I mean, in the past we have a term which is the so-called biojet fuel. I think that is easier to understand. So the basic idea is that we produce fuel, which does not generate as much carbon emission as the traditional, aviation fuel or the Jet A, as we know, and mainly by biosource feedstock, right? So that's why we call it biofuel. I mean, I think this is rather easy to understand because, for example, like the one of the benefit of SAF is that it's the so-called drop-in fuel. So this is the reason why the industry actually welcomes SAF very much. The reason is you can blend SAF like seamlessly with the traditional jet fuel, which means that they don't need to, the airlines don't need to change the fleet. They don't need to, change their engine. They don't need to invest in any new aircraft, and they can use SAF directly. And the nature of the SAF is very similar to the traditional jet fuel. The only difference is that because of the fact that the feedstock, when we produce the feedstock, remember, like if we're talking about bio-based, when we are kind of like producing, for example, like a very popular feedstock for SAF, like is the used cooking oil, right? 地沟油. We know that when we produce the used cooking oil, it absorb CO2 from the atmosphere, right? And then of course, like when you transform the used cooking oil to jet fuel, and then when it burns, it releases the CO2 back to the atmosphere, right? So on a life cycle analysis, then it basically does not emit any CO2. Of course, like most SAF would not be able to achieve 100% reduction of CO2 emission, because there will be like some additional CO2 generated in the production process, right? So eventually, but still, on the life cycle analysis, the SAF would be able to reduce CO2 depending on what type of SAF that we're talking about, right? So now I kind of roughly introduce the definition of SAF already. The basic idea is that why do we call this kind of fuel sustainable aviation fuel, not as biofuel as we did in the past, right? There are multiple reasons, but one main reason is because SAF is a collective term. So we actually have more than one types of fuel that can be classified as SAF, right? We have multiple production pathways. Right? Actually, there are multiple technologies that can help us to produce SAF, right? So as I mentioned, most of this are bio-based, right? You can see the feedstock. For example, these are the 6 methods of creating SAF, but actually there are more, right? More methods that can be used. So feedstock, some of these technologies use biomass, right? Cooking oil, animal fat, and all this. These are the you can say these are the bio-based, but they're not the only types of SAF anymore, right? So we actually have other SAF, which, for example, like the most promising one, is the so-called I'm not sure. I think it's not here, right? So you can see that we have the so-called synthetic jet fuel, or e-fuel, which is another term, right? So the basic idea for the e-fuel is that it is generated by combining hydrogen and also CO2, right? So the basic idea is that if we're able to generate green hydrogen, like you electrify water, with green electricity generated by renewable energy, and combine it with the CO2 extract or absorb from the atmosphere, and then using some chemical process that you can also produce jet fuel, right? So this is clearly not bio-based anymore, right? So it's that's one major reason why we call it SAF instead of biojet fuel, is because SAF includes biojet fuel, but it's more than biojet fuel, right? So we have like more technological pathway to produce SAF. To be honest, like at the moment, you see there are many different technological pathway to produce SAF, right? But there are all like one major, from an economic perspective, one major barrier for this technology is that they are very expensive. So the one currently, there are only like 1 or 2 technological pathway that are really commercialized. I have been working with SAF producers and also SAF users. So I know there are certain technology that is more available than the others, that is also reflected by the cost, right? But even the cheapest SAF nowadays that we can get access to, the main obstacle for their usage is their cost, right? So even the cheapest type of SAF, which will be the HEFA, production pathway, would cost like about 3 times the cost of the traditional jet fuel or the Jet A, right? So if we're talking about the e-fuel, which I kind of mentioned before, it can be up to like probably more than 8 times, but because it's there is no real commercialized e-fuel producer at the moment. So we don't really know, right? But the basic idea is that I'll show you later. But if you actually think a little bit about this, you'll find that e-fuel is a lot more expensive and a lot harder to produce, compared with bio-based, SAF. But they are more promising, right? Because if we are, focusing on bio-based SAF, then one problem is, later I will talk about, like, in the logistics of SAF. One problem is the availability of its feedstock, right? There is only so much used cooking oil, right? Even if we use all the used cooking oil in the world, it will not be able to be converted to, jet fuel that is sufficient for maybe less, 1% of our need for aviation fuel, right? So, there is, in terms of feedstock, bio-based, SAF would actually be, eventually it will hit at the moment because of the demand for SAF is relatively low. So, we don't have this issue, but we know that there is limitation in the feedstock of the bio-source feedstock of the SAF. So, but I mean, at least theoretically, we have abundant, kind of limitless supply of water and also CO2. Right? So these are the only two ingredients that is needed for e-fuel, right? So that's the reason why, although e-fuel is very, very expensive at the moment, it is, the one type, a pathway that we as an industry believe would be the most promising. And so I kind of spent a bit, time to explain SAF, right? So, and then I'm an economist, so honestly, I don't really know technology that much, so I can only give you some background introduction. But what I focus on, one is policy, right? So I have mentioned that the major obstacle to, for the usage or the development of SAF is its cost, right? So eventually we hope that, according to the history or the experience that we obtain from other industries, we know that we need to produce, a large amount or a larger quantity of, like, the products before we can reach the so-called economies of scale, right? So once you reach economies of scale or obtain economies of scale, the unit cost, production cost will be lower, right? So this is the reason why at the moment we need policy support to promote the usage of SAF, or else, like, airlines or the fuel user would not kind of like voluntarily use SAF, right? So this is the reason why the different countries have rolled out different policies. And, there are two different types of policies, available nowadays, right? The most popular one, or at least I would say most of the countries actually adopt the so-called quota policy. The quota policy is very simple. So remember, we can blend the SAF, right? Any percentage of SAF into the traditional jet fuel. So the quota policy is just like, as time goes by, I gradually increase the SAF quota or the SAF the percentage of SAF that needs to be blended into our jet fuel, right? So the one economy or region that has kind of like published SAF policies, EU, right? So EU is always very aggressive in terms of their environmental policies, and the so-called Refuel EU Aviation, policy has been discussed quite a lot. And last year, all the details of the policy has been announced. Right? You can see from this graph, the basic idea is that at 2025, across the European airports, right, the EU airports, the fuel suppliers would need to meet the 2% mandate or quota using SAF, right? So the basic idea is that, like, in all the jet fuel that I supply, or a fuel supplier supply to the European airports, like 2% needs to be SAF, right? So it needs to blend 2%, and this quota or mandate will increase to 6% by 2030, and then the 2035, the 20% up until 70% in 2050, right? So very, very aggressive, actually. there are actually quite some interesting points that is worthwhile to pay attention to, which I will go into details one by one. Right? So this is also review EU, like the EU policy. You can see that another interesting point about the SAR policy or the review EU policy is that it doesn't only have a SAF quota. It actually has a quota within quota. Remember, I mentioned to you that we know that SAF is good, but we cannot only rely on bio-based SAF, right? We also need to develop the synthetics aviation fuel or e-fuel because it's more promising, right? As long as if we consider the feedstock availability. So with, for example, in 2030, by 2030, you see that in the 6% SAF quota, 2% needs to be e-fuel. So this is also mandated. And actually, I have another paper which is presented today in a workshop. So you can see that it actually also leaves some kind of like freedom or leverage for the development of the e-fuel, right? So it actually combines an average plus the minimum policy, which I won't go into details, but I would mention many different points. Some I would go into details about some of the projects that I'm doing right now. But you can see that this quota policy and also the details of this policy has a lot, very interesting topics that can be researched more, right? So as I mentioned, this quota policy is actually the most popular at the moment, right? So not only EU, after EU has rolled out the details of the review EU, you see that a lot of major economies also follow suit, right? So Singapore, UK, and New Zealand, right? So they or like two things. Another, like I mentioned, that one is if we look at the quota itself is quite interesting. But two is that it is kind of surprising that the quota or the mandate is actually not given to airline, right? Airline is actually put into a more passive. You see that airlines is the end user of the jet fuel, right? But they're not really required. The quota is not given to the airline. It is actually given to the fuel supplier, which leads to our supply chain issue. And also like the working paper that I'm going to cover, I think I probably need to go a bit faster. But you can see that this, policies from Singapore, UK, and New Zealand, and some other countries, they're very similar to the review EU policies, although like they're less detailed. And another policy, which is adopted by the US, is actually different. It uses subsidy. So I won't go into details, but the basic idea is that if a producer produced SAF, or a few supplier blends SAF into it's a system, then they will be able to get some tax credit, which is essentially subsidy. So compared with the quota policy, quota policy is more like the so-called stick policy, right? The subsidy policy is more like the carrot policy. Right, so they actually have a very different mindset and also like rationale. But at the moment, only U.S. Adopts the subsidy policy. But most of the other economies, as long as they have a policy, China does not really have a very clear South policy yet. So it is kind of different. So I want to I have already done some research. Like most of my me and my colleague, Professor Jiang, already have a paper published in Energy Economics, and that is discussing exactly the sustainable aviation fuel quota policy. But at that point, we compare this policy with more popular carbon tax, right? Because at that point, the U.S. hasn't released its subsidy policy yet, so we just compare these two. From a theoretical perspective. And of course, later we see that, okay, actually US adopts like the subsidy policy. So it will be interesting to see whether the carrot policy or the stick policy, as I mentioned, right? So the subsidy policy or the quota policy works better. Right, so we have another paper which, theoretically speaking, the previous one is actually quite simple. This, TRB paper is a bit more complicated. We consider many other like factors like information asymmetry, like uncertainty stuff. So we got some interesting results, right? And another paper which is also published like this year, also in TR, actually investigates the impact of this SAF quota or SAF mandate on airline competition. So we feel that for different business models of airlines, so roughly speaking, there are two business models in the aviation world, right? So one is the so-called full service carrier, the big three in China, for example, like Air China, China Eastern, China Southern, they're all like the so-called full service carriers. But we also have the low cost carrier like Spring Airlines, Chunjiu Hangkong, right? So these are, but of course, like in China, low cost carrier is actually not very developed. If you are located in Europe, Ryanair, EasyJet. If you're in the States, then you have like at the moment Southwest is actually the pioneer of low cost carrier. But right now we also have like Frontier, Spirit, all those like low cost carriers. They adopt very different business models, and they will be affected by this quota, and their competition will be affected by the quota. So this paper basically investigates whether there are actually some unintended consequence on the airline competition, due to this SAF mandate. We find that actually, so SAF mandate may distort the competition, which leads to some unfavorable results possibly, right? So I can only go very fast. So policy-wise, we have kind of discussed the details, and now I want to talk about logistics, right? Very, very quickly. I remember I mentioned about the fact that SAF usage is very limited at the moment, right? One issue is supply. As you can see from this article that some airlines, especially those located in Latin America, they want to get access to, they want to use like some SAF, but they're not able to get the supply. So there is a supply issue. There is not much producer in the world, and also like remember we need feedstock, right? Other than e-fuel, which is not really produced at any commercial level at the moment. But if you think about those bio-based, for some countries like China actually has a bit of kind of abundant supply of the feedstock, because we have a lot of used cooking oil, for example. But Australia, for example, I have many colleagues in Australia, and they are pushing SAF like quite aggressively. The reason is also quite easy to understand, right? Because they have the technology. They also have abundant feedstock. Australia is huge. They're also very big in their agriculture, so there will be residual from the agriculture industry, which can be used as feedstock of SAF, right? So you can see that, but the feedstock availability will be very different in different parts of the world, right? So that will create a problem if we want, for example, like say the EU policy, if we want every airport to use a certain percentage of SAF, then logistics will be an issue, right? Because an airport may not be close by or nearby a producer of SAF. If you really want the quota policy to be strictly abided by, then it means that you need to transport your SAF like from probably somewhere very far away, right? Then transportation of the SAF also will generate emission. Whether your emission reduction or emission saving from using SAF will be able to compensate the so-called emission spill over, or this like CO2 spill, carbon spill, like due to the logistics, can also be something that we can discuss, right? So it's up for discussion. So I think SAF logistics, especially given its current limited supply, would also be rather interesting, right? So you can see, if I tell you like more about the aviation industry, right? So these are the top 10 major airports in Europe, and they already account for more than about 50% of all the jet fuel used in Europe. So we do have like this very strong 80-20 rule in aviation, right? So the big airports will use most of the jet fuel, but you have a lot more smaller airport which use probably just a small quantity of jet fuel on a daily basis. If we do need to abide by, as I mentioned, abide by the quota policy, especially when the quota is still very small, right? Then it can be problematic, right? Because as I mentioned, do you separate the production. So it means that you decentralize the production and let production to happen everywhere, right? Which will actually cause lower economies of scale. Or you use logistics, right? And then there will be this carbon spill, or the so-called carbon leakage, right? So both ways are actually not favorable, right? This is the reason why we also have like, okay, so actually this should be chains of custody. So the basic idea is that we also have proposed, other than using the so-called physical segregation, so the logistics issue that we discussed earlier, is based on the fact that, or based on the assumption that we need to strictly abide by the the rule. So it's like every airport would need to use 2% SAF, right? So you definitely will need to use it, or else like you will violate the rule or the law, and then you will be penalized, right? But so this is so-called physical segregation. It means that SAF is SAF, a traditional jet fuel, you cannot consider them to be the same thing, right? So and then it creates the logistics issue that, as I mentioned before, and then we know that inefficiency exists in the system if we strictly follow physical segregation. So there are other more the so-called chains of custody, or you can consider that to be an accounting rule that can be applied, right? For example, book and claim means that you can use like SAF anywhere. So because CO2 flows around the whole world, right? So wherever you cut CO2, it is the same, right? So that's the reason why it is so hard to actually control CO2, in the world, because even if China cuts its emission to zero, if US still keeps emitting, then you will still have climate change. You will still have like global warming, right? So the basic idea is that if you use SAF, wherever you use it, that's fine. So the basic idea is that we assume that we concentrate our usage in some airports, but actually we let every airport, the users of every airport, to pay the price for the 2% SAF that is required, but let them use traditional jet fuel, right? And then also like in those big airports, Amsterdam Schiphol, for example, you use more, right? Probably 6%, 10% SAF, but only also ask the airlines to pay the 2% SAF price, because the price is higher. Then eventually, as a whole, on a system level, then the system uses 2% of SAF, right? We don't need to worry about carbon leakage due to logistics, and we don't need to worry about the loss of economies of scale due to like decentralization of the production, right? So that's the basic idea. And also, of course, we also propose like flexibility period, which is similar to the the mass balancing idea. The basic idea is that, well, I mean, I give the flexibility to the fuel supplier. Remember, the quota is given to the fuel supplier, right? So eventually, I allow the fuel supplier. So, for example, I supply fuel to 10 airports, right? And then I can concentrate my usage of SAF like in just one of these big airports, and the other 9 airports I just use traditional jet fuel, right? So on an average basis, then as long as I can reach the 2%, then I'm fine, right? But actually, both the you can see that Bocom has already been used, but there are actually multiple problems. Also the market may be distorted by either the flexibility period, mass balancing, or book and claim, right? For example, if we talk about flexibility period, then remember we have big fuel supply, which will be national or even international, right? So Shell, BP, they're big fuel suppliers. They supply to many different airports. Then they will be actually placed in a very favorable position in their competition with like the smaller local fuel supplier, right? Because the local fuel suppliers can only supply to one certain small airport. Then they will not be able to have the flexibility as the big fuel supplier. Then in the competition between this large fuel supplier and the small fuel supplier, will be distorted, right? So I don't really have time to talk too much. And another interesting thing to consider is that SAF actually has benefits, more than CO2 reduction, right? We have the co-benefits. So basically, SAF is cleaner and it emits less the so-called local air pollutant. So we have the so-called PM, particular matters, 2.5 PM10, and also like SO2, NOx, like all this will not have like this air pollutants. They will not have global effects, but they have like, local effect, right? So they will affect the community nearby the airport. So if you, allow the big airports to use all the SAF and, but the small airport will need to pay the price, then, this co-benefit would be ripped by the big airports, and the small airports will pay the price, but they will not be able to get this benefit, right? So this will be not very fair. So, all in all, the logistics would create, and also that creates different incentives of the airport. So you can see that major airports in Europe, they actually have their own incentive plan. So other than the government policy, they also set aside money to incentivize airlines to use SAF in their airport. And so you do have like some incentives. You can say that, considering the logistics and airport's role and also like the co-benefit, adding these factors together, it will be very interesting. It's one of our working papers right now. So what will actually be the fair way, whether book and claim is better, whether mass balancing is better, or whether physical segregation is actually the best way in terms of like social welfare, right? So I need to go faster. I only have about 20 minutes left, and we still want to do some discussion, right? So supply chain is another interesting part. As I mentioned, so I will probably skip this part, right? So that I think most of the audience today would be supply chain scholars. That supply chains are very complicated for any industry, right? So we have the supply chain, and one issue that I identify as potential research area is that no one actually, remember I mentioned that the quota policy, they are all given to fuel supplier, not airline. So airlines, although they are the user of SAF, but the quota policy is actually given to fuel supplier. So we look at it, the literature, and we find out, well, I mean, fuel supplier is never the focus of the aviation economics or even engineering research, right? So it definitely would create some issue since right now it is the policy target of these quota policies, right? So we probably need to specifically look at the role of fuel supply, and it plays and eventually you'll find that the fuel supply chain is actually also rather complicated, and it can be roughly classified into off-airport fuel supply, the upper section, and also the kind of like the upper stream and the lower stream. The lower stream will be like the fuel supply within the airport, or the so-called on-airport fuel supply. Right, and so that leads to our working paper. So I need to go very fast. Right? So the focus of this paper is the ownership structure of the on-airport fuel facility, which is part of our supply chain, as I mentioned. Right, so the basic idea, if you look at the current world, right, so there are actually very diverse ownership structure of the on-airport facility. Right, some of them are independently operated. They may be like operated by the government, some government agency, or by some private company, as I mentioned, BP, right? So Shell, those big oil producers, they're also jet fuel producer or jet fuel supplier, and they may operate the on-airport fuel supply independently. Right? So that's what we call the third-party ownership of the on-airport fuel supply. But we also have like two other types of ownership. One is the integration with the airport. I think this is reasonable, right? Because it is within the airport. So possibly the airport will own and also operate this, on-airport fuel supply. So it can be integrated with the airport. But there are also other possibilities where airlines own the on-airport fuel supply. So this is most prevalent. So I would go a bit faster. This is the most prevalent in the US and also Canada. So usually the major users of the airport, like a few large airlines, they would form the so-called fuel consortium or airline consortium, and then they would acquire the ownership and also the assume the operation of the on-airport fuel supply. Right? So this is possible. Right? So all three ownership exist in the world, and we're very interested to know, what will be the best. If we're talking about the fact that there are different ownership structure or different supply chain structure of the fuel supply, one is that what is the optimal decisions of all the participants under this different ownership structure, right? That's the first question. And the second one is also probably more interesting. So which one is the best in terms of social welfare? I know that we probably care, like, depending on the field, right? So some of us care more about profit, but if we're talking about policy, we're also is also concerned about social welfare, right? And also, more interestingly, we know that there will be an increasing SAF quota, right? So this is what we have seen in all this existing quota policies, right? So if we increase the quota of SAF, would that actually, change our answer to our first two questions? Most likely, it will change the first question. Would that change the answer for our second question? And I can tell you a spoiler is that we actually find that, although this is a very preliminary working paper, but we actually find that if you increase the SAF quota, it will actually change the best ownership type, of the on-airport fuel supply. So that I think it has some very interesting policy implication, right? So due to time limitation, I can only go very fast, right? So we build a very, very simple model, right? So we can see that we actually have a quadratic utility function, which give us a pretty simple, linear demand function. So I don't think we can go, simpler than that. The basic idea is that we have like the SAR price and also the top, like, traditional aviation fuel price to be exogenously given, right? So PS and PT, and we know that PS is larger than PT, and the blending proportion of SAF is theta, right? So theta is given, right? It is given by the policy, so it can increase over time, right? And we also assume that for simplicity, we also assume that the landing fee, which is the service charge by the airport to the airline, is also given, is exogenous given, right? Because it's a more long-term decision. And so if as you can see, like, we first consider a monopoly market, which means that there is only one airline in our model. So we can see this is the cost, right? So the cost of the fuel. So we do not really consider, although we say that supply chain, but we do not really consider the production of the SAF, right? So, even this off-airport fuel supplier, it is just the distributor of the blended fuel, right? So you can see that the fuel has already been blended according to the quota policy, right? So theta times the SAF price plus 1 minus theta times, like, the top price. Okay? So eventually this will be the cost or the price, of the fuel that is supplied to the airport, right? So it goes as the cost of the off-airport fuel supply, and then the off-airport fuel supplier will charge a price P off to the on-airport fuel supply, which will further charge a price P on to the airline, right? Eventually, airport will also charge a service usage charge to the on-airport fuel supply when it's independent, right? Third-party ownership, and then the a landing fee T is also charged to the airline, right? So the basic idea is that these four decision makers, they're all profit maximizers. And then we have a social welfare function, which will be the combination of so-called consumer surplus, like producer surplus, which will be just the profits of the all these companies, and also this is a part of the emission negative externality, right? So the basic idea is that emission is bad for society, so we also need to consider its cost. These companies are profit maximizers, so they don't need to worry about emission costs, right? The basic idea is that we assume the part that the percentage of SAF can reduce emission to zero. So what is left is only the emission from using TAF, which will be 1 minus theta times, like, the traffic volume, right? So every traffic generates a unit of emission. And then if we have airport integration of the on-airport fuel supply, then of course like some decisions would be internalized, right? And then eventually you get into these structures. I will not go into details. If we're talking about airline, then the integration will be the other way, and the airport will charge S&T to this combination of on-airport fuel supply and also airline. But the price between on-airport fuel supply and also airline will also be internalized, right? So I think quite straightforward. So for time's sake, I won't go into details. I mean, the comparison is not hard to do, just very tedious. But I can show you like some of our major results, right? So the first one is airport or airline ownership of the on-airport fuel facility leads to increased traffic, reduce airfares, and higher profits for the off-airport fuel supplier, the airport, and the airline compared to third-party ownership, which is very, very straightforward, right? Because we know that vertical integration would lead to lower price, right? Because of the elimination of double marginalization, and also like lower price and also higher traffic or higher quantity, so that this is and also everybody is happy because like the profit increases, right? And however, if we look at social welfare, then a third-party ownership of the on-airport fuel supply would actually lead to higher social welfare than airport or airline ownership when the landing fee, the SAF quota, and the market size are relatively low. So the SAF quota is the most important. So it means that under some scenarios, when the SAF quota is low, actually you prefer third-party ownership. However, when it increases, when it passes a particular threshold, then it will be reversed. Actually, now after SAF quota, which is a certain point, which will be in the near future, right? And then you become, you will become preferring the integration case, right? In this very simple monopoly case, like you will see that no matter airport ownership or airline ownership, they actually converge to the same equilibrium. But that's why we actually have some small extension. But the basic idea is that the major message that I want to deliver is that you do see this changing optimal on-airport fuel facility ownership when the SAF quota increases. So it means that, well, you probably have to pay attention as the airport or as the policy may need to pay attention to, the ownership structure as the SAF quota increases, because you know that there might be a point when you probably need, if you still want to achieve social optimum, you probably need to change the ownership of the on-airport fuel supply, because of the changing SAF quota, right? So to go very fast, we also extend our model to consider oligopoly, right? So we do consider airline competition. And yeah, so I will go fast. So the basic idea is that we consider two airlines, and in the airline integration or airline ownership of the on-airport fuel supply, we only allow one airline. So we consider a symmetric situation. We only allow one airline to integrate with the on-airport fuel supply, and the other airline will still just buy fuel from this on-airport fuel supply, and airline want consortium. And then so we can this is for the asymmetric situation. And then you find that now airport integration and airline integration actually leads to different results. The basic idea is that they also depends on I think under airline competition, when airline owns the on-airport fuel facility, the airline's profit is higher than when the third party operates the facility. Meanwhile, the other airline will be driven out of the market, right? Which is also quite straightforward. We're actually thinking to consider like heterogeneous or differentiated competition. So right now they're fully homogeneous, so there is no differentiation in their service, right? So that is the reason why the airline that is not integrated with the fuel supplier will be driven out of the market. And also airline ownership of on-airport fuel supply will lead to higher social welfare than airport ownership when the market size is relatively small. However, when the market size is sufficiently large, then the comparison may reverse, right? So, when you consider airline competition, then there will actually be some difference between airport ownership and also airline ownership, right? So depending on the market situation, one type of ownership may be better than the other, right? So that's pretty much not consistent, but it is also related to our previous conclusion, right? So in short, I want to leave at least 5 minutes for discussion. So we basically, I have already like stressed like the major takeaway of our research, but again, this is just a very, very simple and preliminary working paper, right? But the basic idea is that we kind of show that if we do consider this SAF supply chain or aviation fuel supply chain in more details, and then also consider the ownership structure of the fuel supply within the airport, then you will find that the SAF quota would actually play a very important role, right? So it can lead to a different optimal ownership structure of the fuel supply. Let me actually, there is some economic intuition, right? So you may wonder why this is the case. A very rough explanation is that remember we consider social welfare to be not only like this consumer surplus plus the company profit, but also like a negative emission cost, right? So when the SAF quota is small, then it means that when you remember integration will lead to higher traffic, right? Higher traffic is good for consumer, it's good for the companies, but it's bad for the environment, especially when SAF quota is low, right? Because when SAF quota is low, then every unit of the traffic will generate a higher, actually at least a relatively high emission. However, this consideration or this concern will go away, or at least it will decrease when you have a higher SAF quota. Right? Remember, a higher SAF quota means that every traffic that you serve, the emission generated is actually lower. Right? The higher the SAF quota, the lower the emission. So it means that the negative part of the social situation to be more favorable to airport or airline ownership, right? So the integration case. So this is the a very rough explanation or intuition of our results, right? So this is pretty much what I want to share. So we have about maybe 4 minutes for Q&A, and sorry for taking up the time.
All
Thank
right.
you.